Welcome to a lesson on writing decimals out in words. For a quick review, decimal notation is used to write numbers according to place value in base 10. A decimal point is used to separate whole numbers from numbers less than 1. So here's our decimal point. So the whole numbers are on the left and numbers less than 1 are to the right. To model place value using decimals, we'll define this block as equal to 1 whole. And because it takes 10 of these flats to equal 1 whole, one flat is equal to 1/10 as a fraction, which as a decimal is 0.1. It takes 100 longs to equal 1 whole, so we'll say 1 flat is equal to 1/100th as a fraction, or 0.01 as a decimal. And because it takes 1,000 bits to equal 1 whole, we say 1 bit is equal to 1,000th as a fraction, or as a decimal, 0.001. So looking at our place value chart, one digit to the right of the decimal point is the tenths, followed by the hundredths, thousandths, 10,000ths, and so on. Let's look at our first example. Here we have 3.21, and we're asked to write the number out in words. Let's first model this using our base 10 blocks. So we'd have 3 ones for 3. This 2 to the right of the decimal point represents 2/10ths, which would be 2 flats, so this is 2/10ths. And the 1 is in the hundredths place value, which should be equal to 1 long. So this represents 1/100th. So 3.21 means 3 and 2/10ths and 1/100th, but this is normally not how we write the number out in words. Looking at the flats and the long, we're going to perform an exchange. We're going to exchange 10 longs for each flat so that we have everything in hundredths. When we do this, notice how each of these was a flat, now it's 10 longs. So now we have 3. Here we have 20 hundredths, and we still have 1/100th here. This is how we write this out in words. We say 3 and 21 hundredths. So again, 3 and 21 hundredths. So notice how if we take a look at our number again, we do have the number 21 to the right of the decimal point, which is how we read this, 21, and because the rightmost place value is the hundredths, we say 3 and 21 hundredths. Let's look at another example. Here we have the number 1.638, and again we're asked to write this out in words. Let's begin by modeling this again using our base 10 blocks. We have a 1 in the ones place value, so we have 1 unit block. We have a 6 in the tenths place value, so we have 6 flats, so this represents 6/10ths. We have a 3 in the hundredths place value, so we have 3 longs, or 3/100ths. We have an 8 in the thousands place value, so we have 8 bits, which is equal to 8 thousandths. So this is 1 and 6/10ths and 3/100ths and 8 thousandths, but this is not how we write this out in words. We do want to get common units to the right of the decimal point. So starting with the longs here, each of these is equal to 10 bits, or 10 thousandths. So 3/100ths is equivalent to 30 thousandths. And because it takes 100 bits to equal 1 flat, or 100 thousandths to equal 1/10th, 6/100ths is equal to 600 thousandths. So in words, we say 1 and 638 thousandths. Again, without using the base 10 blocks, we do have the number 638 to the right of the decimal point, and because the rightmost digit, the 8, is in the thousandths place value, we say 1 and 638 thousandths. Okay, I hope you found this helpful.